Alrighty guys, let's go ahead and get started with the application of forces worksheet. So on this worksheet, it gives us our equation, net force equals mass times acceleration, and it wants us to determine the net force and then find the acceleration of the following diagrams using the second law equation. Cool. So what we're going to do first is we're going to take a look at letter A. And on this one, we notice that we have four forces acting on our box. We have a force applied, a force friction, force normal, and force gravity. We can see that normal and gravity are equal to each other, so they are balanced, therefore it's not accelerating up or down. But force applied and force friction are not equal to each other. So we know that net force is equal to the forces that point to the right, because we consider that to be the positive direction. So it would be force applied minus the forces that point to the left, and that would be force friction, because we consider that to be the negative direction. And we know that that's going to be equal to mass times acceleration. Now that we have our forces, we can go ahead and plug them in. Therefore, net force is equal to 100 minus 30. When we solve for this, we find out that the net force acting on this object is 70 newtons. Now that I know that the net force is 70, I can take that and plug that in to my other net force equation. So I have net force is equal to mass times acceleration. The net force we just said is 70. The mass is given to us, it's right here, it's 25. And acceleration is unknown. To solve for acceleration, I'm going to divide by 25. And I find out that the acceleration acting on this object is 2.8 meters per second squared. Now let's move on to problem letter B. And again, we have four forces. We have normal, friction, gravity, and applied. This time applied is acting in the leftward direction, so we'll talk about that in just a sec. But we see that normal and gravity are equal to each other once again, meaning that it is not accelerating up or down. So let's do this the exact same way we did the last problem by writing our net force equation. We have the forces that point to the right, so in this case that would be force friction, minus the forces that point to the left. In this case, that would be force applied. Now we can go ahead and plug our numbers in for these forces. Force friction is 25. Force applied is 100. If we solve, we end up with a net force of negative 75 newtons. And the reason it's negative this time is because we considered right to be the positive direction. So anything that moves to the left would be negative, or anything that's pointed to the left would be negative. Now that we know the net force, we can use that to solve for the acceleration. Going to take our equation again, net force equals mass times acceleration, and just plug in. Negative 75 for the net force, the mass is right here, this time it's 45, and acceleration is unknown. Solving for acceleration, we have to divide both sides by 45. After we do that, we find out that the acceleration acting on this box should be negative 1.67 meters per second squared. Moving on to letter B, we have four forces again. We have normal, friction is pointed to the right again, gravity pointed down, and applied to the left. If we take a look, we can see that normal and force gravity are the same number, so they're equal to each other, again, meaning that we're not accelerating up or down. So we're going to do the same thing we did before. Net force is equal to the forces that point to the right, which is force friction, minus the forces that point to the left, which is force applied. Now that I have that, I can plug my numbers in. Net force is equal to 50 minus 150. If you solve, you find out that the net force should be negative 100 newtons. Now that we have the net force, we can take that and solve for our acceleration. Again, we know that net force is equal to mass times acceleration. Therefore, that gives us negative 100 is equal to the mass. The mass this time is 30 times acceleration. Solving for acceleration, we need to divide both sides by 30. Doing that gives us an acceleration of negative 3.33 meters per second squared. Last one on this page, we have letter D. 4 forces again: normal, friction, gravity, and applied. Again, normal and gravity are equal to each other, so we are not accelerating up or down. So let's take a look at the left and rightward direction. Net force equals the forces that point to the right, which is force friction, minus the forces that point to the left, which is force applied. Now we're going to plug our numbers in. We have net force is equal to 40 minus 135. If we solve, we find out that that's equal to negative 95 newtons. And then our last step, just like before, is to say that net force is equal to mass times acceleration. The net force that we just solved for is 95. The mass in this problem is 100, and acceleration is unknown. Again, to solve for acceleration, we got to get it by itself, so we're going to divide both sides by 100. Doing that, we find out that acceleration should be equal to negative 0.95 meters per second squared. All right, let's take a look at the back side of this page. So it says determine the missing forces shown below. Positive points to the right, negative points to the left, just like we've been saying. The acceleration of all these objects is 2.2 meters per second squared or negative 2.2 meters per second squared. So we can figure out which one it is based off the arrow sizes. So let's start with letter A over here. Since our bigger arrow is pointing to the right, that means that the acceleration for this problem should be 2.2 meters per second squared. Now that we know that acceleration, we can start solving for some stuff. Let's start with the easy things though, and the easy ones are going to be force gravity and force normal. We know that force gravity is equal to mass times gravity. Since this problem doesn't say, we're just going to assume that we're on Earth here, meaning that the gravitational pull is 9.8. We know the mass is 70, so I'm going to write 70, and I'm going to multiply that by 9.8. Doing so, I find out that the force gravity of this object should be 686 newtons. Gravity and normal are equal to each other in this problem because these arrows are the exact same size, so normal is also 686 newtons. Now that we got that out of the way, we can start solving for force friction. So this is where things get a little tricky. So we know that net force is equal to the forces that point to the right, which would be force applied, minus the forces that point to the left, which is force friction. We also know that net force is equal to mass times acceleration. So for this problem, we need to see what we have. And if we look, we notice that we have force applied, we notice that we have mass, and we also know that we have acceleration. Therefore, when we're using our net force equation, we're going to use this part of the equation. So using this part of the equation, let's go ahead and rewrite it. That gives us 300 for force applied minus force friction, which is still unknown, is equal to the mass, which is 70, times that acceleration, which is 2.2. I'm going to go ahead and simplify all this stuff up here. 300 minus force friction is still 300 minus force friction. 70 times 2.2 is 154. Now, all I have to do is solve for force friction. To do that, I'm going to add force friction to the other side. So I have 300 is equal to 150 plus force friction. And now I'm going to subtract 154 from the other side. 300 minus 154 is equal to force friction. Doing that, we can simplify, and we find out that force friction should be equal to 146 newtons. Taking a look at letter B, we can see that this force applied arrow is bigger than the force friction, and since that's to the left, that means that the acceleration for this problem should be negative 2.2 meters per second squared. So let's start off the same way we did before, and that's solving for force gravity. We know that force gravity is equal to mass times gravity, and we know that the mass of this object is 42, and the gravity is 9.8 because we are on Earth. Therefore, the force gravity for this problem should be 411.6 newtons. Go ahead and write that right here, 411.6 newtons. We can see that gravity and normal are the same size, so normal is also 411.6 newtons. Now that we've got that taken care of, we can go ahead and start solving for force applied. We're going to take a slightly different approach this time and still get the correct answer. So we know that net force is equal to mass times acceleration. The net force for this problem is what we're solving for. The mass, which is 42, because it's right there. The acceleration is 2.2. We know that because it was given to us in our problem. But is it 2.2 or negative 2.2? It's always good to double check, and if we see, we actually note that it's negative 2.2. So I'm going to make this a negative sign right there. If I solve, I find out that my net force for this equation should be equal to negative 92.4 newtons. Now that I have my net force, I can use that to solve for my force applied. Again, we know that net force is equal to the forces that point to the right, that would be force friction, minus the forces that point to the left. I know what all these forces are, so all I have to do is just plug in. Negative 92.4 is equal to force friction, which is 35, minus force applied, which is unknown. After we simplify this, we find out that force applied for this problem should be equal to 127.4 newtons. Go ahead and write that back up here. Alrighty, we got two more problems left. Let's start with C over here. Again, we see the bigger arrow is pointed to the left, so that means that our acceleration for this problem is going to be negative 2.2. And again, acceleration is meters per second squared. Now that we got that taken care of, let's go ahead and figure out the force gravity. We know force gravity is equal to mass times gravity. The mass of this object is 25. Therefore, force gravity is equal to 25 times the gravitational pull, which is 9.8. If we do the math, we find out that force gravity for this specific problem should be 245 newtons. We know that normal and gravity are equal to each other, so normal is also 245 newtons. Now, let's go ahead and solve for the force friction, but first we need to solve for the net force. We know that net force is equal to mass times acceleration, and we know that the net force in this case is unknown, so we're going to write net force as net force. We know the mass is 25, and we know the acceleration is 2.2. No, we got to double check. If we look, we can see that the acceleration for this specific problem is negative 2.2. So it's always important to just double check your work to make sure that you guys aren't making any mistakes, because everybody makes the mistakes. So negative 2.2. When we multiply all that stuff together and we solve, we find out that our net force should be negative 55 newtons. Now that we have that net force, we can use that to solve for our force friction. We know that net force is equal to the forces that point in the positive direction minus the forces that point in the opposite direction. I'm going to take one more step before I plug my numbers in because I want to get force friction by itself. So I'm going to add force applied over to the other side. So I have net force plus force applied is equal to force friction. Now I plug my numbers in. I get negative 55 plus 75 is equal to force friction. If we solve, we find out that force friction for this problem should be 20 newtons. Last one, we have our object with the bigger force pointed to the left. Therefore, that means that my acceleration is going to be negative 2.2 meters per second squared. Now that I know my acceleration, I can start tackling this problem. The weight is mass times gravity, and we know that the mass is 57, so we're going to take that and plug that in for mass. 57 times, and we know that gravity is 9.8. So doing so, we find out that the force gravity should be 558.6 newtons. Again, we can see that gravity and normal are equal to each other, so this is also 558.6 newtons. Now that we have that, we can go ahead and solve for our net force. We know that net force is equal to mass times acceleration. The mass of this object we just identified as 57. The acceleration, it's moving to the left, or it's accelerating to the left. It actually doesn't matter which direction it's moving in, just which direction it's accelerating in. And it's accelerating to the left, so that's negative 2.2. When we solve for this, we find out that our net force should be negative 125.4 newtons. Now that we have that net force, we can use that to solve for force applied. I know that net force is equal to the forces that point to the right, which is force friction, minus the forces that point to the left, which is force applied. Let's go ahead and solve for force applied first, and then we'll plug our numbers in. So I'm going to add force applied over to the other side. So I get force applied plus the net force is equal to force friction, and then I'm going to subtract net force back over here. So I end up with force applied is equal to force friction minus the net force. When we plug our numbers in, we get force applied is equal to force friction, which is 40, minus, and this is negative 125.4. Plugging all those numbers in, we end up with a final answer of 165.4 newtons.